Welcome. Thank you all for joining this webinar about developing Bluetooth Low Energy applications quickly with boards, tools, and resources from STMicroelectronics. My name is Clemens Valens. I work for Elektor, and I will be assisting our guest presenters, Manuel Marcias and Yvon Rannou, both from STMicroelectronics. Manuel Marcias is a field application engineer for STM32 products. Hello, Manuel. Nice to meet you. How are you doing?
Hello, Clemens. All good. Thank you very much. Very excited to be here with you today.
Great. Our other guest is Yvon Rannou. He is member of ST's wireless marketing team. So, hi, Yvon. How are you today?
Very good. Thanks, Clemens. And nice to meet you, guys.
Thank you. Welcome. So, this webinar is to show and demonstrate how to develop Bluetooth low energy applications quickly with the help of system on chips, pre-certified modules and development boards, training resources for self-learning, and of course the STM32 Cube ecosystem. This webinar will be very helpful when you join the STM32 Wireless Innovation Contest. I hope you can see it, as we are running now in Elektor. This project submission deadline is February 19th, 2024, next year. We will paste the link to the contest in the chat box. There will be a lot of information. We have a long presentation, so don't worry if you can't follow along with the presentation, because we are recording this webinar and it will be available afterwards on the Elektor TV channel for replay. As usual, at the end of this webinar, you can ask questions, and you do this by typing them in the Q&A chat box, which is in the right bottom corner of my screen, at least. Well, having said that, let's get started. I will launch the presentation. Yvon and Manuel, you mute yourself, please. Here we go.
Hello, everybody. Designing a project with wireless communication might be challenging. Challenging in terms of wireless expertise, but also on how to select between multiple offers available on the market, while looking for the best technology, the best software and tools, and the best supplier when it's time to talk about wireless microcontroller. All right, you are at the right place. Following this webinar, you will find many answers. My name is Yvon Rannou, Technical Marketing for Wireless. Welcome everyone to this webinar about STM32 Wireless. For today, our agenda is divided in 3 parts. During the first part, I will introduce you to the STM32 Wireless portfolio and ecosystem for 2.4 and sub-gig communications. The second part will be presented by Manuel. He will demonstrate the STM32 wireless ecosystem with demos, practical examples, and collaterals you need for a new project with STM32 wireless. Finally, we will conclude together this webinar with a Q&A. The STM32 portfolio is segmented into 5 categories visible on the left. Microprocessor on the top, high-performance microcontroller, mainstream, ultra-low power, and finally, wireless microcontroller in the yellow box. Today, we will focus on the wireless microcontroller family for sub-gig and 2.4 communications. On the sub-gig, the WL5 is a powerful dual-core architecture supporting different modulations, including LoRa. STM32WL3 is a new sub-gig SoC, state-of-the-art in terms of RF performance and power consumptions. For the 2.4 GHz, ST has entry-level BLE SoC with the WB0 series and multi-protocol SoC single or dual core with the WB and WBA series. The portfolio of STMicroelectronics has grown to have more than 60,000 customers, over 10 billion STM32 devices shipped since our first device released in 2007. All our STM32 devices have a 10 years commitment, which renew in January of every calendar year. Let's start with the 2.4 wireless microcontroller. So first questions. Which wireless protocol are supported within the current ST portfolio? With Blue Energy and STM32WB SoC, ST is covering most of the 2.4 wireless applications, addressing them with the most suitable, tailored, and cost-effective device. In fact, STM32WB and Blue Energy offer support Bluetooth Low Energy Mesh, 802.15.4, based mesh protocol like Thread and Zigbee, and also latest CSM Matter protocol. When we consider BLE in concurrency with Thread or Zigbee, these are served by the STM32WB series, while the Blue Energy is tailored for BLE and BLE mesh-based applications. STMicroelectronics has the largest portfolio of Bluetooth Low Energy and multi-protocol products on the market today. Our wireless microcontroller series start from Cortex-M0 in the Blue Energy to our dual-core Cortex-M4 and Cortex-M0 Plus with the STM32WB series. The flash offering starts at 1 MB in the WB55 and the WBA series, and reduce as you move into the Blue Energy series. The latest addition to the family is the STM32WBA series with the Cortex-M33 and the security options inherited from the STM32U5 ultra-low power platform. If you are looking for a Bluetooth BLE 5.4 compliant device, majority of our wireless microcontrollers comply to 5.4 standard. With all our Bluetooth Low Energy, we integrated security hardware to ensure Bluetooth Low Energy connections is secure. The STM32WBA series takes this further by integrating a Cortex-M33 trace zone, PSA from ARM level 3 and CZIP level 3 compliant. STM32WB is a dual-core wireless application processor with the following split. Cortex-M4F dedicated to the end applications, Cortex-M0 focused for the wireless stack. On STM32 series, you can recognize three main families. WB1, tailored for BLE applications with 320 KB flash and 48 KB RAM. Very powerful, still getting benefits from the dual-core architecture. In the middle, the WB3. Support BLE, Thread, Zigbee, and in general 802.15.4 base protocol in time division mode. Memories are up to 512 KB flash, 96 KB RAM. Additional peripheral like USB 2.0, Quad SPI, and with execution in place, and analog peripheral. Finally, on the right side, the superset WB55 that is very rich in terms of peripheral, including LCD driver and capable of running multi-protocol in concurrent mode, with its memories up to 1 MB and 256 KB SRAM. At a glance, the rich STM32WB series wireless portfolio. Package offering are on the bottom, with all flash and RAM combinations on the left. You can find the right fit for your applications, depending on the flash memory units and the feature required. From home of you knows STM32U5 ultra-low power Cortex-M33 microcontroller. Okay, we took this brilliant architecture. We combine it into a single die with a brand new high-performance radio coprocessor on physical layer. With this, we made the new STM32WBA. This product targets CZIP level 3 security certifications, thanks to the enhanced security feature. By architecture, the STM32WBA is targeting low-power applications, applications where IoT security is a must, applications where low cost or high RF power are the driver. On the STM32WBA, we use a 40 nanometer process node that grounded to add many features on a large flash containing the platform cost. Overall, BOM costs are also reduced thanks to the high integrations, as we see in the next chart. STM32WBA 52 is the first product of an extended series that will be further expanded very soon. The STM32WBA 52 is focused on Bluetooth Low Energy applications, while the series is capable of concurrent multi-protocol. As said, it is based on the Cortex-M33 100 MHz with trust zone, up to 1 MB flash and 128 KB RAM. It does support Bluetooth Low Energy 5.4 with long range, 2 megabit, and advertising extensions. It enhances security thanks to the AES and PKA, side attack resistance, and active RTC, tamper, and of course the ARM trust zone. It provides high power output up to 10 dBm, still being an ultra-low power radio. It enhances low power consumptions thanks to an ultra-low power architecture derived from the STM32U5. Thanks to the 100K cycle endurance on this up to 256 KB flash, you can finally count of an EEPROM like flash memories. And last but not least, BOM is reduced thanks to the integrations of the balloon, 50 ohm antenna matching, and as well the single crystal. But power without full control is useless. Here, the STM32 Cube ecosystem supports all the phases of your project from the first idea up to the final test, and we will dig into this later on. On the left side, you can notice the STM32 Nucleo 64-pin daughter board with the microcontroller RF board on top. This evaluation kit embeds the STM32WBA 52 SoC in QFN48 package, offer 35 GPIOs, Arduino and Morpho connector, fully RF certified. STM32WB5MMG is a tiny module with integrated antenna, all in one small form factor, 7.3 by 11 mm, exposing 68 GPIOs available for your applications. In fact, the module is based on UFBGA 129 pin full-feature dual-core from the STM32WB55 with 1 MB flash and 256 KB RAM. The module is designed to reduce your BOM cost, allowing a two-layer PCB without external component. All the RF complexity is managed by our design, and the module comes pre-certified as listed here. And to start your evaluation journey, a discovery kit is available, fully supported by the STM32 Cube ecosystem. Okay, I touched ecosystem many times during these presentations. What ecosystem really means? A complete design journey from configuration to application monitoring. From the left, STM32 CubeMX is a graphical configuration tools means to select the base SoC or module you need to configure and allocate all the peripheral to adjust all the needed clock, and also manage middleware like operating system on the wireless stack. STM32 CubeMX support code generations for many well-known IDE like IR, Kyle, and STM32 Cube IDE Eclipse-based. When you are done with your compile and debug tools, on top of the programming, thanks to the STM32 Cube programmer, you may want to monitor your software and test your radio. STM32 Cube Monitor is a fantastic tool to allow you to monitor variable in your application compile in release mode. Finally, STM32 Cube Monitor RF is used to test the radio on the radio stack. For BLE, for instance, you can play with the HCI command or set the radio in a given mode to run performance or pre-certification test. After the 2.4 GHz connectivity, let's have a look on ST offering for sub-gigahertz. ST has a complete offer to address all sub-gigahertz market, starting with sub-gigahertz transceiver with Spirit 1 and Spirit 2 LP, also called S2LP, supporting many modulations on protocol. For wireless SoC, ST have single and dual core with all needed modulation on protocol, including LoRaWAN stack. Some extended protocol support, like wireless M-Bus, MIoT, are also possible with external ST partner. STM32 sub-gig SoC are also part of the STM32 ecosystem. The STM32WL is the first wireless microcontroller designed for IoT and long-range communications, supporting multi-modulations for sub-gig, including LoRa. This system on chip is a single die solutions integrating our STM32L4 platform, ultra-low power microcontroller on the LoRa-enabled IP. Thanks to the high level of integrations, STM32WL helps to reduce the bill of material cost, but also simplify development and reduce time to market. The STM32WL portfolio offers today single and dual core options, QFN48 and BGA package, security hardware functions, and 2 embedded power amplifiers, plus 15 dBm and plus 22 dBm. STM32WL is a wireless microcontroller supporting 4 modulations options. First, LoRa modulations with LoRaWAN protocol, GFSK compatible with Sigfox, but also GMSK and BPSK modulations. Thanks to this 4 modulation support, STM32WL platform is also capable to handle many proprietary protocol or standardized protocol. Around the STM32WL wireless microcontroller, we find the same wireless ecosystem as for the 2.4 GHz. Hardware ecosystem includes evaluation boards like the Nucleo board for flexible prototyping and some reference design. Many tools like STM32 Cube MX, STM32 Cube Monitor, and STM32 Cube Programmer. Now let's hand over to Manuel, our STM32 technical FAs. Okay, Manuel, it's time to teach us how to surf and find the fastest way to shorten our learning curve and become quickly an STM32 wireless expert. Thanks to all for your attentions.
So let's start this journey. I'll show you everything you need to get up and running with STM32WB, starting from STM32 Developer Zone. First, let's begin from st.com. We click on STM32 Developer Zone and we select the MCU branch. Our dev zone is the best possible gateway to any STM32 developer. It provides everything you need to start your development journey with STM32. It includes comprehensive access to MCU portfolio, dev kits, eval boards, software tools, embedded software packages, specific users application, and many resources you can refer at any time in the development stage. As we want to learn more about WB and connectivity especially, let's click on Wireless Connectivity button. Here we have all the RF protocols and standard ST is capable of providing you, including BLE, Zigbee, Thread and Matter, as well as long-range technologies such as LoRa and Sigfox. At the bottom of the page, we can then click to the ST Wiki link to get useful information for our hardware and software bring up with STM32WB series. Before starting to explore our wiki page, it's important to underline that everything you see in this presentation is applicable in case you want to start your project with STM32WB chip on board or modules. Our wiki platforms aims at assisting developers to get started with STM32. We have a dedicated wiki for MPU and one for MCU. It contains many information to discover your preferred STM32 series and associated ecosystem. We put a lot of effort in creating this content to make it seamless for you to get started with any STM32. Inside the wiki, we click on Solutions and then on Connectivity. Here, you may want to start with Bluetooth Low Energy, for example. As you can see, we have a main index on the left panel, and you can also find the navigation bar on the right, which is including the subchapters for each paragraph of the wiki article. Here, as we can see, we have 3 major links which are of our interest: hardware setup, software setup, and how to build an STM32WB application starting from CubeMX. In addition to that, scrolling down a little bit, we have a link to the most important MOOCs, our massive open online courses that can be an additional guide for you during the bring up process, as well as most relevant application notes. Okay, maybe some of you might think, I would like this content in PDF format to make it available offline. It's also possible to do that in just a few clicks, as you can see here. We can now have a look at the hardware setup chapter. Here you have a detailed guide on how the STM32 dual core architecture works, and also a description on how the memory map is structured. At chapter 3, there is a subsection dedicated to fuse and wireless stack update using STM32 Cube programmer. For those of you who may not be familiar with it, FUSE is the acronym for Firmware Upgrade Service, which is basically our stack bootloader that resides in flash memory and runs on Cortex-M0+. It acts as a root security system, authenticating the selected wireless stack loaded by the user. At the bottom of the page, there is also a link to a YouTube video explaining how to handle stack loading in case you need further details. Now we click on STM32WB Fuse article. Here we have a detailed page describing how Fuse works and where it is located, as well as the various versions we released. You can also find useful guidelines on what are the differences between STM32WB5 and WB1 in terms of bit addresses and memory sizes, together with some answers on the most common questions you may wonder when working with Fuse or stack upgrade. Latest version of Fuse provided is 1.2.0, and it comes pre-programmed in any STM32WB chip or module. In case you face different versions of Fuse, at chapter 4 of this article you have the upgrade procedure that you can follow along. Moving again to the left column index, you have a quick guide on how to build a BLE project that you will find in CubeWB firmware pack we will see later on, together with a section detailing size and support of BLE stacks. As you have learned, the stack architecture of STM32WB is super flexible, and we have different stacks with different sizes and features to fit with all your use cases. For example, I need to run a heart rate profile. Which stack should I use? Here, at chapter 1.4 of this article, we have a good summary of stacks needed for each specific application. Now, coming back to the main index, you may wonder why is there a dedicated session for WBA? Well, this is because WBA architecture differs from WB, and you will learn more about it in a dedicated webinar that will come soon. In addition to what we have seen above, we also have a wiki article to get started with software development to build your FWOTA, firmware update over the air, a T-Command server, or also an advertising application. On advertising extension, you will find a guide on how to set up an extended advertising example between client and server with clear indication on which stack is needed and at which address it needs to be downloaded. You know that different stacks have different sizes, so a different base address is needed. All of this is very well detailed in our comprehensive release note document that we will see later on. What is very useful is surely STM32WB CubeMX article, which is a super detailed guide on how to build a step-by-step peer-to-peer server with write and notify characteristic using our STM32 CubeMX. As you might know, CubeMX is our fantastic code generator that enables you to easily handle peripheral configuration, middleware and clock trees with few clicks. In this section you will really touch with your hands how much CubeMX can make the difference into your development schedule. So we have now seen how to get started on firmware level, but what about mobile application for testing examples and validating our proof of concepts? Great news is that we have plenty of choices. We are on Google Play and Apple Store with free official apps. And for those of you who may wonder on the most suitable application to be used with a specific UWB example, you can find here the whole list. So, we have seen how many content and how it is easy to get started with Bluetooth thanks to our STM32 wiki. Same approach applies to Zigbee and OpenThread. We really think our STM32 wiki is a great reference to boost your productivity when starting with STM32. Okay, so we have talked about examples and release notes for the stacks, but where can I find them? To answer this question, we can now move to STMicroelectronics GitHub page, which contains all STM32 Cube firmware packages. It's enough to type in the search bar STM32 Cube WB and click on the result. Here we land to the latest version of the Cube WB firmware package. As you probably know, an STM32 package is made of CMSIS model, HAL, LL drivers, BSP drivers, USB, RTOS, FATFS middleware, and in case of WB also Zigbee, OpenThread and BLE stacks. Inside the project folder we can find the examples supported for all STM32WB existing evaluation boards, including also the WB1M connectivity expansion board, which is coming soon. What is very interesting and useful for you to know while starting any STM32WB chip or module based design is to have a look at the release note by clicking here. On the release note, we can see at first the main changes introduced in the latest Cube WB. All relevant information as well as Cube ID and third-party ID support is here. And this is the main reference to understand what's new in our Cube WB release. If, for example, you are interested in a release note related to any specific drivers, you can click here. Moving along in the page, inside projects, you can find another link which is leading you to a detailed list of all the examples delivered for every evaluation board, with the important information related to the availability of a cubemx.ioc file and related platform supported. Now, going ahead, in the same page, we find a section with release note for any binary stack delivered. This is way more detailed versus the previous one we saw at the beginning of this web page. For example, by clicking here, we can find all the information related to the internal tracking cases and fixes applied to Zigbee, BLE and OpenThread stacks. In addition to that, On the side columns, we have a link to declaration ID for every certified stack. Going on the left column, we have a very useful step-by-step guide on how to flash the wireless coprocessor binary via SWD JTAG by ST-Link, and also on how to flash the coprocessor binary by system bootloader. Now, coming back to the top of the page, the wireless coprocessor binary table is essential to learn the starting addresses of the stacks during the flash procedure, which depends also on the memory size of the related WB product. As we return to the main page, we also have release notes for drivers and middlewares, which are included in Cube WB package. At the very bottom, we have the history of all the previous release notes packages that have been released since 1.0.0. So, I hope that now you are able to navigate proficiently into our STM32 Cube WB to find the information that are relevant for you and your application requirements. As you know, all projects on ST official GitHub undergo a rigorous inspection. However, the projects you see in our official repo are just a fraction of what internally ST employees have developed. So why not providing this project as is by creating an additional hub where our community can grow its knowledge? This is the brilliant idea behind our STM32 GitHub hotspot. The STM32 GitHub hotspot is a co-development space for ST employees made to share their prototypes of software example running on STM32 products with our wide community. It's enough to go on GitHub and type STM32 hotspot. These examples can come from different sources: trade shows, proof of concepts and prototypes, or validation code. The idea is to open millions of lines of code developed by ST experts for STM32 products that could be reused by the community. All the source code published in this repo is delivered by ST under business-friendly licensing terms, meaning that any developer can reuse our source code on an STM32 without worrying about copyright restriction. You see, in this repository we have plenty of examples related to STM32 wireless product line, such as Matter Device Overthread for STM32WB or STM32WBA Motion Sense, which combines AI and RF running a machine learning application on an STM32WB, helping to classify between stationary, walking, and running. We really hope you will take some time to explore and enjoy this additional development hub we created for you. Okay, and if you need an operating system, so even if WB can be used in bare metal by using a sequencer utility, another important topic to be touched is operating system. Thanks to our flexible STM32 Cube ecosystem, you have the freedom to choose between FreeRTOS and AzureRTOS in conjunction with STM32 CubeMX. To get an example on FreeRTOS together with wireless stack implementation, we can come back to our STM32 Cube WB software pack, Wikicom project, and on our preferred Nucleo board, and under application, and for example BLE, we have an heart rate profile implementation using FreeRTOS that you can use as a starting point. Okay, this is very nice, but I want to start with AzureRTOS. What shall I do? In this case, we can come back to our main page of the STMicroelectronics official repository, and on the search bar, we can type Xcube AzureRTOS WB. This expansion pack includes the RTOS, which is the ThreadX, and the USB device stack, called USBX, together with the file system and network stack. In addition to that, A FreeRTOS adaptation layer is also included, making it easy and quick to migrate from FreeRTOS to Azure RTOS for STM32 user. And what if I want to start with Zephyr RTOS? In this case, you can have a look at zephyrproject.org, where there is a dedicated section for STM32WB.
Okay, so we have seen all the deliverables related to STM32WB, but what about the new STM32WBA that Yvon just introduced? The STM32WBA is a wireless microcontroller that is designed to provide a complete solution for your 2.4 GHz wireless application. It's based on the Cortex M33 running at 100 MHz and Bluetooth Low Energy 5.4 radio. It comes with half a meg or 1 meg of flash, enhanced security and low power performance. Now, when it comes to find information about the STM32WBA, one of the best resources available is the STM32 Wiki. As you can see here, on our wiki page, we have a dedicated tab section targeting just STM32WBA. Going through it very quickly, we can see in the BLE hardware setup section the new concept of Nucleo explained. So we have an MCU RF board where the STM32WBA is mounted, and we also have a mezzanine board which embeds Arduino connector, ST Morpho headers, and ST-Link V3 modes for debugging purposes. Moving on the next chapter, we have, for example, a description of the STM32 Cube WBA MCU package. So here you can see, for example, a description of the software architecture and short description of all the examples that are available in the STM32WBA Cube software pack. Also in this case, you can see we have Bluetooth LE 6 standard profile examples implementation, ST-LE BLE proprietary profile, like for example data throughput or P2P client and server, as well as some example to use ThreadX as an operating system. Moving on in the wiki, we have a section on which we explain how to build a BLE project. Starting from STM32 firmware WBA, there's a description on how to build using IR, Kyle, and CubeID. And also a dedicated session on how to install firmware using STM32 Cube Programmer. Interestingly, on the top, there is a description of the BLE stacks option for the STM32WBA. Depending on the wanted feature, we have basic or full link layer and basic and full host stacks. As you see, the architecture is different from the STM32WB, as here we have a single core handling application and radio, and the stack is automatically linked in every project, so no need to flash it separately like we were doing for the STM32WB. Moreover, we also have a dedicated chapter on how to build from scratch a P2P server application using CubeMX that is going to guide you through all the steps you need in order to achieve a P2P server implementation on your Nucleo board. And in the last chapter, you also see an interesting example on how to manage trust zone and Bluetooth Low Energy stack on STM32WBA, leveraging, of course, on Cortex M33 trust zone. So you just saw how the STM32 Wiki provides a range of deliverables and examples in order to grant you a hands-on approach to learning about this new product. So whether you are a seasoned developer or just getting started with the STM32WBA, the STM32 Wiki is an invaluable resource that can help you to get the most out of this powerful wireless microcontroller. Now it's finally time to move from theory to practice and see how easy it is to build a Bluetooth Low Energy application using STM32 and associated Cube ecosystem. In this demo, I will be presenting you something we quickly saw during the STM32 Wiki walkthrough, which is the P2P server application. Peer-to-peer is an ST proprietary profile that you can use to exchange information between a client and a server. In this case, our Nucleo will be a server, and we can read the right characteristics. For example, we can blink an LED when the characteristic is written from the client and have a notification on our client when the button on the server is pressed. Of course, client can typically be your mobile phone, but in this case, we have a surprise. So who is our client? Coming back to our GitHub hotspot, we will type STM32WBA web app. We click on the link. We enter on the home page and we select Web Bluetooth STM32WBA. So what's that? This is a web interface which is using Web Bluetooth API that can be used to establish a Bluetooth Low Energy connection and exchange data with an STM32WBA Nucleo board. Basically, we will use our laptop as a client interfacing directly with our server board. Very nice, isn't it? So in order to get started with the example, we will now open STM32 Cube MX. On STM32 Cube MX, we will open the example page, as we want directly to start from one of the examples that are already existing inside STM32 Cube WBA software pack. Once the page is open, we will type in the search bar peer-to-peer server. And we need to be sure to select the BLE peer-to-peer server associated to our Nucleo WBA52CG board. After that, we just need to start project. Select if we want our directory and install the STM32 Cube firmware pack. Now the firmware pack has been downloaded. We have here the CubeMX view with the possibility of configure all the peripherals inside the SoC. As we want to be quick and generate our first project on Nucleo WBA, we just need to go to Project Manager, select our toolchain, in this case STM32 Cube IDE, and just click on Generate Code. We select Cube IDE workspace. And after that, here we have our BLE P2P server project imported already in the IDE. Now we just need to build and now we have to flash our application inside the Nucleo STM32WBA. So we have now connected our STM32WBA Nucleo to our laptop using a micro USB cable, and we are ready to program the board. So we click on the play button to program the board. Okay, the board is now programmed. In fact, you see a green LED blinking, meaning that the board is starting to advertise. Now let's open our STM32 WBA web application to interact with this peer-to-peer server. So we can now open our web Bluetooth app and we click on connect. We see the P2P server advertising and we'll click on pair. After that, the P2P server is highlighted in this blue bar. We click on it. And here we have the two characteristics exposed, write and read. So for example, if we click on light, we can turn on and off the light on our peer-to-peer Nucleo server. And if we enable the notification on the server and we click on button 1 on the Nucleo board, you see that the virtual LED is toggled on and off. And of course, if you click on info, you have all the log from the very first connection with the server to the read and write we did on the two characteristics. So I hope you enjoyed this demo, which was simple but also very quick. And I hope to have explained you how to quickly go through the STM32 Cube Max to easily build a Bluetooth Low Energy application leveraging on STM32WBA SoC capabilities.
Now, let's quickly touch our dedicated tool to support RF application, the STM32 Cube Monitor RF. As you might know, STM32 Cube Monitor RF is a tool provided by ST to help designers to perform RF tests on Bluetooth Low Energy, Open Thread or 802.15.4 MAC. In case of BLE, it can be used to control WB via ACI commands, configure Bluetooth Low Energy beacon, manage file over-the-air transfer, run RF tests, and discover Bluetooth Low Energy device profiles and interact with service. With the latest release of Cube Monitor RF, we now have the ability to save the BLE log info in a CSV formatted file. This is really very helpful. In just a few clicks, we have the complete log in CSV file of all our HCI commands and related events. Basically, the STM Cube Monitor RF includes everything you need to speed up your tests and get ready for your certification steps. We are quite at the end of our fantastic journey. We really hope that you have found this overview on deliverables useful for your next design with STM32WB. You have seen many contents, but you still might have a specific question or doubt. Please feel free to reach out to us and post your question on STM32 community or open a case in our online support portal. This is all from my side. Thank you very much.
Well, that was very interesting. I hope you learned a lot from it. As I said before, this webinar is to support our contest. I will show it again. I pasted the link in the meantime in the chat box. STM32 contest. We don't have a lot of time left, so we will go on with the Q&A immediately. Where is the button? The button left. We changed buttons. There we are. So we will start with the first question. Is that okay with you, Manuel, Yvon?
Yes, sure.
Okay. So this is a very long question. I will not read it out. Why did ST change the format of documentation?
Okay, so I can take these questions. So thanks for this question. So in ST, we have two different families, the WL5 series and WL3 series. So this is two different families. but we are merging both family in one combined STM32 ecosystem. So you are probably already familiar with the WL55 ecosystem. WL3 is a new port we have just introduced. We are introducing on the market right now, and the ecosystem migration is ongoing. But feel free to contact your ST representative if you need any support on these new families. Thank you. Next one.
Okay, the next one, we have a question about frequencies. Do you plan any device with both sub-gigahertz and 2.4 gigahertz frequency?
Okay, thanks for these questions, also very interesting. So today in ST we have two different product lines to cover majority of the sub-gig applications, but also very rich product line for the 2.4 gigahertz. And we'll continue to expand on the 2.4 with some new protocol in the near future. Now, of course, there is a trend on the market to combine both in one SoC, sub-gig and 2.4. So this is planned on the long-term roadmap. Thank you.
Okay, here we have a question. Why do files include libraries and headers from Semtech?
Yeah, so I can take this one. Thank you, because it's a very interesting point. So the reason why you see Semtech source code inside the libraries that are generated by CubeMX is because the STM32WL is at the moment the only one SoC in the world who has on a single die an integration of a Cortex M4, then optionally also a Cortex M0 Plus for handling the security over your LoRa communication, but also a Semtech 12.6X transceiver. So the reason why you see Semtech libraries inside the project 3 is because, in fact, we rely on the Semtech driver to interface via SPI with the Semtech transceiver on this monolithic architecture on a single die.
Okay, here we have another technical question. Is it possible on the STM32WL55 to expose receiver demodulated data on a GPIO pin?
Pretty interesting one. You cannot achieve that on the WL55 because the Semtech transceiver is not exposing this functionality, but you can definitely do that on our Spirit 2 radio and even on the STM32WL3.
Okay, so you need another board for that. Another question here. Are there similar wiki pages for the BNRG2A1 and IDB05A2 expansion boards? So far, searches on the internet only provide very limited information.
You will have the same level of documentation that we have now for STM32WB and WBA and WL in a couple of quarters from now. So as you saw, our wiki contents is growing pretty fast. So we are adding a lot of contents for supporting in general all our STM32 portfolio. And we definitely invest in adding more contents related also to the Blue Energy family. Thank you.
Okay, very good. Question. Does the LoRa radio support angle of attack detection like BLE?
Mm-hmm. So in this case, of course, you cannot compare the two protocols for what is called the real-time location system. So LoRa, by definition, does not support a real, I think here we want to say angle of arrival or angle of departure detection. So we cannot handle that on LoRa, even because of the physics, because with sub-gigahertz, it's way difficult to have an accurate spatial resolution. But there are few applications and few possibility of using LoRa for real-time location system, especially in agriculture, very similarly to what is done with Sigfox. But this means that you will have tens, hundreds of meters of accuracy, not few centimeters like you can do right now with the Bluetooth AOA and AOD.
Okay, here we have one about certification. Is a product based on the WBA also to be certified worldwide, or can you skip the certification?
Okay, so I can take this one. Thank you. So yeah, of course, all products that need to be to support BLE will need at some point some BLE certifications for the end product. So on the ST side, usually we make the certification for the QDID. So we have all the certification already available for the WB series, for the Blue Energy, and WBA. This is also available. So you can reuse this QDID certification for your final product certifications.
Okay, that is good news. Another question, deep technical. How can in one core WBA 52 CG real-time requirements for communication stack be guaranteed?
Yep, so a good one, because this is key difference between a WBA and WB. So on WB, by the way, you have two cores. So the M0 Plus is completely taking care of the radio, and the M4 can take care of the application. So in case of hard real-time requirements, definitely the WB is the one you should look at. But the WBA is still capable of handling very well stack and application, because the whole interrupt vector and the whole ISR system puts the radio link layer in highest priority. So basically, for sure, you will be automatically notified by the an interrupt from the link layer at every connection interval. So definitely your application should take care of serving the radio interrupt before the rest. But the very nice thing is also that this radio interrupt definitely will be automatically disabled as soon as you move in low power mode. So to answer in one sentence, the structure itself on the WBA 52 in terms of interrupt handling is designed to be able to give you a good real-time functionality when dealing with stack and application. But if you really have real hard real-time requirements, like can be, for example, motor control, you should look into WB. So the two options still have a lot of sense, and they are pretty differentiated still.
Okay, here we have a new question. For my application, the STM32WBA52 with all the security features looks too complex. Do I really need to be a security expert?
No, of course not. So usually speaking, the requirements for security are increasing, and that's why we put a step further with the WBA 52. This is a new product that is certified PSA level 3 and CESIP level 3. Now, ST has developed many different security services to help you guys to develop security in a very easy way, with a lot of code example as well. Now, if you do not need security, you can just do not use a trust zone or do not use security services. This is really easy to configure for your final application, with or without security, depending on your product requirement.
Okay. Back to position detection. Do you have an example where it is used?
I can take this. Unfortunately, I don't have on top of my mind a way to tell you where to find an example. I think it's very niche application for the moment, RTLS with LoRa, because for LTLS, looking into the sub-gigahertz space, maybe you'd better look into Sigfox, which in fact is exactly born to do that. So maybe if you are interested in position detection with sub-gig, you should look into Sigfox.
Okay. And then back to the cores. Does dual core device share the same memory?
So they share, of course, we are talking about STM32WB. They are sharing part of the same memory. So we only have one flash memory accessed by both core, and both core are talking via an interperipheral communication. So the answer is yes.
Okay. And then we have a last question. We're nicely on time. What about matter and thread?
Okay, thanks for this question. So this is definitely a very important trend. So ST is supporting thread connectivity with mesh network from the WB, so already for a few years, and now Matter is coming on top. So on the WB55, for example, you can support Matter over thread applications for the end node. And ST is also working a lot in the Matter connectivity to prepare some reference design for end nodes, but also for Matter gateways and Matter bridge. So you will see, stay tuned, you will see a lot coming next year on the Matter applications with STM32.
Okay, I think that a lot of people will like that. Well, at least on my clock, it is 5 o'clock, so our hour is over, which means that I have to end this webinar. Once again, don't forget to join the STM32 Wireless Innovation Contest. The link is in the chat box. I can paste it once again while I edit. Let me put it into the chat box. Should be, there it is. As I said at the beginning, this webinar will be available for replay in a few days on the Elektor TV channel. We hope to see you again for the next Elektor webinar, which is in about 2 weeks on the 14th of December. And it will be about a special Elektor Expressive edition that is coming up. Thank you, Manuel and Yvon, for doing this webinar with me. And thank you all for attending. And last time, don't forget to join the contest. Goodbye.
Thank you. Bye.
Thank you. Take care. Thanks a lot.